Alright, so at this point we're looking at the last few questions of paper 1 of the May-June 2021 paper. So at this point we got to question 10. We'll start answering from question 10 onwards. Okay. So in question 10.1, still busy with calculus. So in question 10.1, we are told the graph of f of x equals ax cubed plus bx squared plus cx plus d has two turning points. The following information about f is also given. F of 2 is equal to 0. So what does that tell us about our sketch? F of 2 is equal to 0. And the turning point? No. It's your x-intercept. Not so. So your x-intercept is 2. So when I draw this here, okay, so we cut your x-intercept at 2. Alright? I think I'll make it a bit bigger because of, see, we've got halves and ones and so on. Okay, x is 2. So that takes note of that there. Then we are told the x axis is a tangent to the graph of f at -1. It's a tangent. So what does that mean? The graph is turning at 1, -1, or bouncing off at -1. Not so? So the graph is either going to do that or that at -1. You will agree with that?
Yes.
Then we told that f dash of 1 is 0. So what does that tell us? It's another turning point. However, that turning point is at x equal to 1. Okay? So x equal to 1 is a turning point. So at this point, so far, this graph would either be doing that, turning here, turning there, and going down. There's one scenario. Not so? Or the graph could be doing that, turning on this x equal to 1 and cutting 2. One of the two. Not so. But what does this tell us? F prime of a half is greater than 0. What does that tell us? The gradient is at x equal to a half is more than 0, which means to say what? It's positive. So if the gradient is positive, then the graph is increasing. Not so. If it's negative, it's decreasing. This part of the graph, is it increasing or decreasing? Decreasing. The gradient positive or negative? Negative. Here? Positive. Why? Because it's increasing. Here? Negative. Did you see that, people? So if we go and we say, okay, x, f prime of a half is positive. If that is 1, then a half is here. Not so. So is this one, is this gradient positive or negative here? Positive. So it's actually this graph we need to do. Why? Because at f prime of a half, the gradient on this line would have been negative. You guys understand? So let's go again. Everything off. Let's read from the top again. So you all have you saw now what the graph is going to look like. So we say f of 2 is 0. So there we go. Graph is turning there. The x-axis is a tangent to the graph at this, so that we know the -1. So the graph is bouncing off the axis there, or it's going to turn what we call turning point on that axis. F prime of 1 is 0, the turning point is at 1. And f prime of a half is positive, which means the gradient is positive at a half. So the graph has to go up, then down. And there's the graph of f of x. Okay, any confusion? Very simple, huh? Okay, let's look at 10.2. In question 10.2, we are told that O is the center of the semicircle passing through A, B, C, and D. The radius of the semicircle. So that means to say from O to D is x minus x squared. From O to A is x minus x squared. And that. It's all the same units. Not so. So the radius is x minus x squared. Then we are told that x is greater than 0 but less than 1. So when we solve for x, it must be a value between those values. We are also told that ABO is a right angle triangle at O. It's a right angle triangle. So what can be used in right angle triangles? Pythagoras, the Pythagorean theorem. Okay. So this is going to be x minus x squared. That's your radius, the length of the radius. Okay. The question says, in 10.2.1, show that the area of the shaded part is given by. That's story. So if you look at the shaded region here, how are you going to calculate the shaded region? Semicircle, yes? Minus the triangle. So in other words, what you're calculating is the semicircle, the area of the semicircle, minus the area of triangle. But look here. What about this and that? That included. Now, if you say the area of the semicircle and you minus the area of the triangle, remember this part here is only that part. But if we subtract the area of the triangle, I've accounted for that part, but then I'm left with this small part and this part. Understand? So that is not going to work for us. Anybody else? Yes? If you can find the length of AB. Yes? Is that the semicircle?
No, it's not.
It's not the semicircle. That is not the semicircle. Wait, before we dismiss that, wait. So you're saying AB, you just check, no? I know I said it's not, but for me first, to make sure. So I'm going to do according to Pythagoras, no? Is that correct? Is that okay? So that's going to be x minus x squared all squared. So that would be 2 x minus x all squared squared. The square root thereof be root 2 into x minus. No, without the square. I took square root both sides. So the length of this line AB is that, but we want the radius of it. No? Is that what you're saying? So you're going to get AB, so radius. So I divide by 2. It's going to be root 2 over 2, x minus x all squared. It's not the same. So this length from there to there has to be the same from there to there. Yeah. No, can't be. So there's going to be pi r squared. Let me just check. Okay. Anybody else? Asma, you alright?
So,
Yes.
I didn't find the area of the two cone.
Two?
I was going to say 2D cone, but
2D cone.
that's
This is a what's the name shape. This is not a 3D shape. Cones are 3D.
I realized that.
Okay, I'll tell you. Let's look at it this way. If you look at this triangle here, right? And I take this triangle and I rotate it. What do you notice? Okay, that's will not fall exactly onto this now. But I rotate this triangle in such a way that this is what I actually have now. We have a semicircle. This is must be line AO now. And C. B became C now. Can you see that, people? So that's what you got. And that shaded region will still be the same. Not so? So I'm going to calculate the shaded region now. The quarter of a circle. There we go. So we say now the area of the shaded region. Put it here at the bottom. So it's going to be area. People, when the question says show that or prove that, we don't have that in the sum. It's only in the solution. In your final line. Don't write, start off by writing that. Okay? The examiners looks like, see you writing that there, then they assume you use that for your calculation. Okay? So leave, when it says show that or prove that, leave it out. You must just have in conclusion, we have got that as a shaded region. Okay? So, as we see for the shaded region, it's going to be a quarter of a circle minus the area of the right angle triangle. Not so? So what is the length of the base of this triangle? X minus x squared. And the height? Same. Why must it be the same? Radius. So radius. Not so? So we go. The quarter. How do you calculate the area of a circle? Pi r squared. Not 2 pi r squared. Pi r squared. How do you calculate the area of a triangle? Half. Base times perpendicular height. Not so? So let's go with that. It's going to be a quarter pi. What's the length of the radius? X minus x squared all squared minus half base, which is x minus x all squared times x minus x squared. But that is squared here, not so. That's x minus x squared all squared. It's the same. Okay? So I can say the area of the shaded region is a quarter. So what I'm going to do is I'm going to take x squared or x minus x squared all squared as a common factor. You all okay with that? If I take that out as a common factor, what am I left with? So x minus x all squared, you're left with a quarter pi minus half. Okay, can you see this is coming along already? You see that part? I'll get from here. You see, I took out the common factor. Not so? So, the binomial square, that's no problem. This here would give us what? X squared. That times 2. It's going to be negative 2x cubed. And the last term squared will be plus x4. Not so? What's your LCM in the second bracket? Half. Your LCM is 4. Not a quarter or a half. Your LCM. Oh, 1 over 4. Yeah. So what must 4 be multiplied by to get 4? 1. So it's 1 pi. Not so? 2 multiplied by what is 4? 2. So, and that is that part of the solution.
So you have x squared
So you make a mistake?
yeah, this way.
You make a mistake. Okay? It's okay.
Daddy, what is that the
Where?
x minus 2 over?
Not the X, my girl, man. It's a pie.
Okay, yeah.
Huh? Fine. Right, you guys understand? Any confusion? Right. Now, in the next question, people, the reason why they give you this here is because if you didn't manage to get the area of the shaded region out in this question, you can answer the next question based on this information. Understand? You see, the maths people are very nice people. We just want to help you guys. But you guys are other type of people. No? You just don't want to help. No? Am I right? Yes. So what happens is they give you that formula so that you can actually answer the next question. You guys understand? So in 10.2.2, the question says determine the value of x for which the shaded area will be a maximum. First derivative. Set it equal to 0 and so forth. You understand? Determine the value for x for which. Remember, when we come back to this, the value for x has to lie between 0 and 1. You guys understand? There has to be a value between those. So let's go with that. People, this is a constant to us. Not so? So if we got, for argument's sake, you got 4 into x squared minus 4x. And they ask us to take the derivative of this. Say this is f of x. So the derivative of this would be 4 into 2x minus 4. I've taken the derivative there, which is 8x minus 16. Not so? But you guys can say, but we have to first multiply it. Not so? Let's check what happens if we multiply first. But f of x equal to 4 into x squared minus 4x, which gives us 4x squared minus 16x. Apply the derivative. It's going to be 8x minus 16. You say, oh my word! Well, so what does this actually tell us? It's the same, yes, but what else is it saying? It tells us that if there's a numerical coefficient there, there's a numerical coefficient, it's a number in front, numerical. Then we can apply the derivatives with respect to x there. Can you see that? And then multiply the what's the name out afterwards. So you all should agree that this coefficient is also numerical. It's a number. It's a constant. Not so? So I can apply my derivative straight onto that and then multiply that out afterwards. You all okay with that?
Yes.
Nobody's confused, no?
No.
Let's take all this off quickly. Right. So what I'm going to do is I'm going to apply my derivative to that part and keep the constant outside. So this is the area. So the derivative of the area with respect to x equals. Apply my derivative on the bracket. So it's pi minus 2 over 4 into. What would apply the derivative? What do we get? 2x minus 6x squared plus 4x cubed equals 0. So I drop this. Not so? So what do we do now? Now I can multiply that in the constant, the constant. Not so? But why do I have to multiply? I can just divide it throughout. Not so? So I divide both sides by pi over 2, pi minus 2 over 4. So what would this give us? 0, yes. So that cancels, and that's what we want. 2x is a common factor. I'm then left with 1 minus 3x. I'm not factorizing this here. 2x is a common factor, so it's 1 minus 3x plus 2x squared equals 0. So I say that is equal to 0 or that's equal to 0. Not so? What is this to us? Trinomial. Not so? So x is equal to 0 or where is this coming from? From this 2x. Not so? So I say 2x equal to 0, x equal to 0. Okay? Oh, this is now a trinomial. Again, don't keep yourselves brave if you can't factorize a trinomial. Now, I explained to you yesterday, none of your friends is going to know if you're going to use a quadratic formula. No? You use it. So that is equal to, or x is equal to. Use your quadratic formula. Your coefficient of x squared is 1. 2, sorry, so it's going to be 2. Negative 3 and 1. So x works out to be 1. Or x works out to be a half. Not so? Again, where did I get that values from? I must first write that in standard form. 2x squared minus 3x plus 1. Okay? That's where that comes from. We say, there are 3 solutions here. But what did the question say? Determine the value. Did it say values? No, it says value. Which means to say? One solution. We say, okay, now how are we going to discard the other 2 solutions? It must be, according to the restriction. That's where this now comes in. Let's change it to green now. The restriction. The restriction says that x must be greater than 0, but less than 1. So which means to say what? Can't be 0. Can't be 1. Therefore, x is equal to? Yes?
So, the previous example we did in green showed us about the constant. Why did you multiply and you could divide?
Divide by 2x. Who can tell her why I didn't divide by 2x?
No, sir, with this one, with the 5.
Say again? This here?
Yes, you divided, but the previous example you multiplied
Into the bracket, like it.
Yes, but that was the constant also before this. You took it off the board.
Where is it? No. Oh, we had 2 sums here.
Yes.
No. I was illustrating to you or showing to you that if I had multiplied the constant in, or if I kept the constant outside, it would have given you the same answer. As long as it's a number, I can apply the derivative inside the bracket. That's what I was trying to show. Okay. So the question was not why I didn't divide by 2x. No? But who can tell me why did I not divide by 2x and factorize the 2x? With the x. We never divide by a constant, by a variable. Otherwise you're going to lose the solution. Otherwise we wouldn't have picked the solution up here. Although it's omitted in this case, not always omitted. So never do we divide by a variable. Okay? You guys understand? If the yes. Okay, next one. The coefficient, I mean the constant. We had multiplied this in. No problem, you should get the same answer. So another thing is at this point, if the question was, determine the maximum area of the shaded region, what would we have done different here if that was the question? The question was, determine the area of this maximum, the area of the shaded region, if that was the question. We would have taken this x equal to half, and then we substituted back into this formula here. And then we would have gotten the maximum area. Remember that the maximum area occurs at the maximum value of x. In this case, which is half. Okay? So that's what you need to consider at this point. For this question, the optimization question is often left out by learners. Okay? The one question where they're really testing you on your skill on optimization is the first one. The next question, the question that follows that, is your application of derivatives. And everybody can do that. Not everybody, but I say most of you guys can do that. So you know how to apply the derivative. Remember, when they ask you maximum or minimum, it's first derivative. Okay? Yes?
What was it other two values not equal to something?
Who can tell you why I omitted this? There's a restriction. The restriction says x must be greater than 0, but less than 1. So I might. Can it be equal to 0? No. Can it be equal to 1? No. That's right. Okay. Any other questions? Right. Let's go to question 11. Get rid of that optimization completely. We don't want to see it anymore. Then we get to this question and we say, okay, let's rather go back to optimization. Right, probability. Two events, A and B, are such that. A lot of bullet points in this paper, no? Such that events A and B are independent. If you are told it's independent, what comes to mind? The probability, the independent rule. The probability of A in the section B is equal to probability of A times probability. Yes. Yes. Whenever you read the word independent, you write that down first. Okay. Events A and B are independent. Second bullet. The probability not A 0.4. So then from here we can then say, but hang on. The probability of A is equal to 1 minus the probability of not A. And what rule do we call that? The complementary rule. A and not A will always add up to give you 1. Okay? So which means to say the probability of A is 0.6. So I got that. You see that? You see the probability of B is 0.3. So what do I have now? The probability of B. Yes, now the question says calculate the probability of A and B. Where do we get A and B from? Is that there? Not so? So the probability of A and B is equal to the probability of A times probability of B. So that's going to be 0.6 times 0.3. That's going to give you an answer of 0.18. Alright? You all agree with that?
Yes.
Any confusion? Any confusion, people? No. Samia, you alright? Sounds is not getting you down. No. Okay. It's the trick ball that's getting you down. No? Right. Okay, that's why I made it small. So we are told that a survey was conducted among 150 learners at a school. Okay? So there is 150 learners. What does E stand for? Sample space. Okay. The S is 150. the following observations were made. The first thing is the probability that the learner selected at random will take part in only hockey. Hockey only. So that explains why here is 0,024. Not so? Then we are told that hockey and debating, D, and not chess. So we must omit chess. Okay, can't overlap the chess subset. So it says hockey and debating, but not chess. So you take that one out. That's why 0,14 is there. Okay? This is grade 11 probability, no? Then we are told that debating and chess but not hockey. Debating and chess but not hockey is 0,12, that is this value there. Then we are told that hockey and chess but not debating, 0,02. Explains that one there. Right. We'll take it up a bit so we can do our calculation. My calculator is there in the way. Okay. So the question is the probability that a learner selected at random participate in at least one activity is 0,7. So what does that mean? At least one. Can he participate in 2?
Yes.
Yes. Can participate in 3?
Yes.
Yes. So that means to say that if I add that, this, that, and this, it all adds up to 0,7. Not so? So what is M then equal to? 0,3. Why? So they are complementary events. Not so? It will always add up to the sample, which is 1. In this case, the sample is 150. Okay? But what does this represent? This is units from 0 to 1. This is that is your probability spectrum from 0 to 1. But the number in the group is 150. You understand? So if you want to work out how many takes part in hockey only, you say 0,24 times 150. Then I'll get a number of learners who does hockey in that, only in that category. Does it make sense, people? So already we know the value of M without reading the question. Okay? Then we are told that 15 participate in all 3 activities. And hang on. All 3 activities is 8. So 15 lies there. 15 out of 150 is there. You guys understand? Yeah. So let's answer the question. Let's see what's the question. The first question. Determine A. The number of learners that participated only in debating is the same as the number of learners who participated only in chess. So that probability and that probability is the same. So you got B's in both instances there, or subsets. The question says determine A, the probability that the learner selected at random participate in all 3 activities. So in other words, that is going to be, it will be 15 out of 150, which is 0,1. So put 0,1. Okay, you guys understand?
Yes.
Right. Now, the stuff gets exciting now. No? We don't like the easy sums. We like the ones you must think about. No? Keep on telling yourself that lies. You will start believing it. Yes? Yeah, I almost thought you were going to ask me a good maths question. Okay. So in question 11.2.2, we are told that Determine M. Oh, this is easy. Determine M. We got M already.
Yeah.
Not so. Okay, I know you guys are upset. You're looking for that big sums, no? Determine M. The probability that a learner selected at random does not participate in any of the three activities. Of course, we spoke about that already. So M is 0.3. Put that there. Alright. Come on, where's that big question? How's it? Okay, so let's take this out. Oops, I can't take it. So in question 11.2.3, they say how many learners play only chess. So in other words, if I calculated B, I've done the job. Not so. We say, okay, what do we know? We know that if I add that all of these together, what do I get? 0.7. If I put it plus that 0.3, it's going to give me 1. Not so. So he says, how many learners? So what must I do? I must work out, once I've got that probability of B, the value of B, I must work out the number of learners as well. You guys understand? So let's go with that. So it's 11.2.3. So, yeah, we've got double, 2 B's here. So it's going to be 0.1 plus 2 B's plus 0.12 plus 0.02 plus 0.14 plus 0.24 equals 0.7. So 2B is equal to, put in the calculator, 0.7. 0.7 minus, sorry? 0.08. Okay? That's going to use 0.08 divided by 2, 0.0. But have you answered the question? No. The question is, how many learners play only chess? So it's going to be the number of learners that plays chess only is 0.04 times 150. That gives an answer of 6 learners. Make sense? Okay. Okay. I think there's one sub question left. We'll leave that for tomorrow. That is 11.3. No? So for homework, I want you guys to start with paper 2. Alright. What's your question, Asma? 11.2.3, yes? Okay, you answered your own question. Okay. Is there any other confusion? The question was, why are you multiplying with 0.0? Yeah, because the question in the first case was, what is the probability, or the value of A is going to be the probability. Whilst in 11.2.3 the question was the number of learners. Understand? If the question in 11.2.1 was, how many learners took part in all 3, then the answer would have been 50. Okay? But since it's the probability, I need to lock it up. People, enjoy the rest of your day. Good afternoon, class. Don't forget paper 2 for tomorrow, okay?